Dear students of physical geography, since last episode we are trying to understand the planet Earth in terms of its interior and also the crustal movements in this direction. In this present episode we are going to the movement of continents or the wandering of continents, where we have a theory called theory of continental drift by Wegener. So as usual, in this episode also we have 5 subsections. One is introduction to the continental drift theory. The second one is theory of continental drift, Pangea, subsequent movements. Third aspect, position of the continents with special reference to India. The fourth one we are going to understand about this theory is evidences of continental drift theory as per Wegener. And the last fifth aspect is arguments against the theory of continental drift by Wegener. Now let me come to the introduction to the theory of the continental drift. Planet Earth has evolved to the present state of having gaseous atmosphere, liquid hydrosphere, solid lithosphere and biosphere. In its 4,600 million years long history of evolution, in the last 200 million years, we have seen drifting of land masses bar continents. Earth crust, particularly the uppermost lighter crust, which is called Sial, which in turn constitutes all the present continental land masses with a variety of rocks, has undergone changes. It is even now subjected to several types of dynamic movements, where drifting of continent is one which is put forward by the early second decade of 20th century. Though it was criticized for a lack of information on why such drift took place in the beginning, the growth of geophysics and empirical geology by 1960s have resolved the criticism of Wegener's continental drift. Now the theory of plate tectonics provides scientific base for such continental movements. However, the original theory of Wegener's still has relevance in understanding the degree of permanency of continental land masses and their directions of movement, and also the correlation of empirical evidences of early beginning supercontinental land mass. Pangea, which is drifted apart since 200 million years to present position of continents. This theory also helps us in clear understanding of what portion of this supercontinent is also known as Gondwana landmass and Laurasian landmass. In fact, it has laid foundation for the theory of plate tectonics and even to some extent the mountain building of tertiary times of the Earth's geological history. Reference to primordial sea of Tethys can be clearly understood only with the help of the theory of continental drift. Shift of geographical poles are suggested with some proofs by continental drift. Also, Wegener worked out a definite geological chronology for the supposed movement of continents, equator and poles. Now friends, let me come to the second aspect of this theory, that is the theory of continental drift, its various continental portions and movements. The theory that Earth's continents move gradually over layer of semi-molten rock underneath, that is SEMA, the Earth's crust. It is thought that the present day pattern of continents is derived from the supercontinent Pangea, which existed approximately 200 million years ago. If you look at the figure number 1, you can clearly see that in the geological time scale, and also followed by a continent showing all continents together, that is the Pangea. Alfred Wegener first postulated the idea of horizontal drift of the continents through the magma in 1912. Wegener was basically a German meteorologist and tried to explain major climatic variations in the geological past across the world. He believed that there are clear geological evidences of climates resembling those of equatorial, tropical, Arctic regions in latitudes far removed from lands where those climates prevail today. The solution to the enigma evidently involves the movement of either of the land inclimates. According to Wegener, the continents of the world were at the beginning of the time, that is the Permo-Carboniferous period, all closely joined together, and in this composite mass was known as the Pangea. If you look at figure 1 again, figure number 2, you clearly understand the top figure indicates the Pangea, where all continents, that is the land masses, together. This was surrounded by a deep ocean, and certain portions of the land masses were under shallow water. At some later stage, due to unknown causes, certain portions of this land mass drifted towards south and north. The result was that Americas were formed in between Americas and Europe. Africa came the Atlantic Ocean. Similarly, Australia drifted northwards, got separated from Antarctica. Somehow, he maintained that Australia drifted southwards first to become separated from the Gondwana land, and in its place flowed in the Indian Ocean and also the Bay of Bengal. So in these figures, you can clearly see all the three different stages of the continental drift. The first figure shows the situation of the all land masses around 200 million years back before present, and the middle figure, or the figure B, shows that the continents around 50 million years before present, and the last figure, that is figure number C, the downward one, shows the present situation or the present location of all the continents in the world. Scholars who are in favor of Wegener believe that all southern lands were once parts of Gondwana land. When it broke apart, its central part drifted towards the South Pole to form what is known as Antarctica. For some time, the South Pole was near Durban, that is near Natal of Africa. Huge land masses of north of equator then ultimately formed Laurasia or Angara land mass. Now, once again, you have to clearly refer all these figures. You can how the whole total Pangea on either side of the equator became northern Laurasia, southern Gondwana, and the present continent further got drifted and all that. Now let me come to the third aspect of the today's talk, that is the position of the continent with special reference to India. Now in most of the textbooks you don't see a special reference to India, but here I have tried to give you the position of India with special reference to continental drift. Now let us go to the details of that. A simple glance at figure number 1 shows that around 200 million years ago, as per Wegener's theory of continental drift, all continents were together, formed a supercontinent, namely the Pangea, which we have already learnt in detail. See, this period, geological time, that is the early Mesozoic era of the Earth's history, in which Earth was passing through Triassic period. By that time, the giant forests were buried to form coal fields or coal deposits, which is popularly, we all know that, Permo-Carboniferous period. And first giant dinosaurs, marine and flying reptiles of living creatures were also, they were there at that time of the geological time on the Earth's surface. If you closely look, figure number 3A, now you see number 1 represents North America, number 2 represents Africa, number 3 represents most part of Laurasia or Eurasian continent, number 4 represents South America, number 5 represents our own Indian subcontinent. Watch carefully the Indian subcontinent. In fact, in the middle of the Indian subcontinent at that time, the equator was passing. Now we are just quite away from the equator. In fact, closely look at the position of India. It is around 200 million years. It is attached to Africa. Hardly there is any gap, and even Madagascar is not visible around 200 million years back. Number 6 represents on the map 31A the Antarctica. Number 7 reference to Australia. So all these were together, which we repeatedly mentioning as Pangaea or the supercontinent or the megacontinent. Now you look at the figure number 3B. So continents, as we have moved a bit, so this refers to the situation of the continents around 50 million years before present. So you can see India has moved a bit, see in between Madagascar has formed, and even see there is a clear see visibility of formation of Arabian Sea, and also Africa see also is an independent continent, and all other continents have taken shape to a great extent, and all this is explained in my text. See, I will go once again to the details. There was a considerable continental drift across Pangaea. Present continental land masses were taken almost clear shape. India had moved away from Africa northeastwards, but still equator was passing through middle of India, indicating equatorial fauna and flora might have ruled over our country. Antarctica and Australia were also moved away from the Pangaea. You have to see closely that figure. And southeastwards, respectively. While Arabian Sea was very narrow, Bay of Bengal was a deep sea and Indian Ocean was formed. Atlantic Ocean was not so wide enough, while North and South America were formed. It is worth remembering by that time the earth entered into its Cainozoic era, which we are in now. Of course, different episodes are there, epochs, in which a very important period, namely tertiary period. This period, according to Wegener, westward pushing of the South and North America, leading to the formation of Rockies and also Andes Mountains. Northward pushing of sub-India led to the drying up of Sea of Tethys and also rise of Himalayan mountains from its bed, which are also known as tertiary young-fold mountains. Further drifting of continents towards west, north and south, southeastwards also led to the formation and the position of the present-day continents. If you carefully observe any map of the world today, particularly the one which is given as 3C actually, as you see clearly the continents of the present-day position. The intervening basins between the continents are occupied by the oceans of the present times. Now let me come to the next aspect under the fourth section of the today's talk, namely evidences the continental drift. Now there are arguments for and against continental drift, and this section goes into the evidences of the continental drift. Wegener, being a meteorologist searching for evidences of variations of climate in different parts of the world, came across number 1, jigsaw fit of the coastal lines of Western Europe, Western Africa on one side, and that of North America with Europe on the other. Leaving some minor parts, the bulge of Brazil would fit in the Gulf of Guinea. The North American continental line would closely fit in the indentations of the coast of Scandinavia and Western Europe. Like that, the bulge of Ethiopia on the east coast of Africa fit in the curve of the coastal line of Western India and Pakistan. This all requires some kind of careful observation of all the figures that are given with reference to this continental drift. Northern tip of Australia can very well fit into Bay of Bengal. You look at that Bay of Bengal, can also accommodate this Australia. All this matching of continents made Wegener to believe that perhaps that all the continents had once been a part of great land mass Pangaea. Then as the earth resolved and land masses eddied around and finally broken into pieces, the Americas moved west leading to formation of Rockies and Andes in North America and South America respectively. As said earlier, that India moved northeast towards while Antarctica moved southwards. Second evidence is by observing geological similarities like fossils, fauna and flora on the opposite sides of the Atlantic Ocean, Wegener concluded that in the Paleozoic era, earlier to 2000 million years, all the continents were part of the Pangaea. But in the Permo-Carboniferous period, this land was broken into two parts, north and south of the Sea of Tethys. In fact, present Mediterranean Sea is the remnant of this Sea of Tethys. Further, in support of Wegener's theory of continental drift, there are 6 arguments, and they are as follows. Number 1, around North American continents, there are measurements between land masses and countries which have indicated that a possibility of continental drift. Greenland is gradually drifting westwards, that is towards North America, at the rate of something like 32 kilometers per year. Whereas the distance between the Greenland and England has decreased. That clearly shows that westward movement of the Americas. Such drifts of land masses reported on western side of the North American continent too, indicating continental drift. Now, another aspect, in support of the Wegener's continental drift is about 130 million years ago, the Indian subcontinent stood at 46 degrees south latitude. As a result of continental drift, it now reached nearly 9 degrees north latitude. This happened in about 30 million years. It means that the continental drift from 46 degrees south latitude to 30 degrees north latitude took about 100 million years of geological history. Another evidence in support of this theory is that certain living animals of Scandinavia have been observed to plunge into sea. This taken to be or conversant with land beyond, which has since drifted. This extraordinary migration shows that once the Americas were joined with Europe and Scandinavia. So another evidence supporting the theory of continental drift is the flora and fauna, their fossils on either side of the Atlantic, that means South America as well as North America, and also most of the Africa are similar, demonstrating thereby that the two portions must have been sometime together. For example, the Falkland Islands and the shores of the South America resemble in their plant life, animals and geological structure with South America more than the mainland of South America. Chinese scientists of late have found convincing evidence that it was possible to walk to China from the land now at the South Pole. Their discovery of a northwestern China of animal fossils like Lysistrausus and Canamaride is strikingly similar to those of same period from Antarctica, South America and South Africa supports the view which those lands now remote from one another were once closed and linked by land bridges. Another evidence in support of the continental drift is the geological history and structure of land on both the sides of the Atlantic are similar, that is, have Gondwana series. In fact, in peninsular India, we have rocks similar to Antarctica, Australia, as well as most part of Africa, as on the mainland, and subsequent formations along the coastal lines. One of the last evidence that is quoted here in support of the continental drift is the great ice sheet which spread over a great part of the earth during the Permo-Carboniferous period has left its mark on South America, South Africa, South India and Australia. This shows that all these regions which are now part of different continents were once members of one composite block, that is Pangaea and South Pole, at that time was in South Africa. Please students remember that this ice age which just quoted as a support of the continental drift is actually different from the Pleistocene ice ages. Now let me come to the last aspect of the today's episode, that is arguments against the theory of continental drift. Some of the critics are of the view that this theory does not indicate any force adequate enough to bring about the drift of continents. The continents can only drift due to a tidal force 10,000 times as strong as it is at present. But such a force seems to be impossible, because such a thing would stop the rotation of the earth in 1 year's time. It is believed that this will also produce radioactivity and convection currents in the SEMA, which will have far-reaching consequences. The second argument against the theory of the WEGENER'S continental drift is that WEGENER'S theory presupposes SEMA to be in a liquid state and Sial is supposed to be floating over it. There is also contradiction of this assumption that SEMA buckled in the edges of drifting land masses. These two positions are paradoxical, because the first one presupposes the same to be liquid, while the second one regards as it is sufficiently solid. But SEMA has wax-like rigidity, and during mountain building or buckling process, it is sedimentary rocks which are folded and not the Sial itself. The third argument against the continental drift theory by Wegener is, though jigsaw fit which we saw recently of certain continental portions seems all right, but critics say this in time only to some extent, but not all. The fourth argument against the theory of continental drift is there are criticisms also on time and directions of the drift. But the studies related to Earth's magnetic measurements by eminent scientists like M.S. Bucket of England and H.H. Hess of USA from Princeton University show they have done the study of split of Asia, Africa, along with fossil magnetism and the spread of ocean floors, as respectively have given support to the theory of continental drift. Of late, as recently as 1964, the theory of plate tectonics came into being, and we are going to learn more about in the next episode. Further scientific studies on the position of the continents and spreading of ocean floor through geophysical analysis, growth of geographical information system and its application along with the global positioning system, too have contributed to the wandering or the drifting continental land masses. Thereby the criticism of Wegener's theory has been substantially reduced. Thank you.